Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
Let's add to our skills now and solve radical equations. To solve a radical equation, you have to first identify where is the variable located. To solve any equation, we always want to solve for the variable, right? Well, in this case, the radical equation has the variable inside the radical, which means it's the part of the radicand. So in order to be able to solve this, we first need to get rid of the radical. And the way we do that is applying powers. Now, this is a square root function, which means the index is 2. So I'm going to apply a power on both sides in order to simplify out this index of 2. So because the index is 2, I'm going to apply a power of 2 on both sides. This power of 2 will simplify with the index of 2, which completes the root, and thus extracts whatever's inside, which is the radicand. The radicand is 2x minus 1, that comes out, and on the right side we're squaring 7, which is 49. Now hopefully you can see that this is just a simple two-step equation. Now we have a solution. However, with radical equations, in the process of solving these, we could end up generating what's called an extraneous solution. So in other words, that's a solution that actually does not work in the original problem. So what we have to do now is check. So what we do is we take our solution that we got and we substitute it into the original equation that we're trying to solve for. If the solution is true, if the statement is true, then the answer stays. If the statement is false, then this is no solution. It becomes an extraneous solution. So I set up my system, or my check as is. I take my number that I got, I substitute in wherever it tells me to, which says right here, and then I put a little question mark above the equal sign. Now I'm not going to move any terms from left to right or right to left. All I'm going to do is simplify both sides and see if I end up with a true statement. In other words, both sides are the same. As you can see, I ended up with a true statement here. Therefore, this is going to be my true solution. Let's look at another example. In this particular case, now we have our radical equation, but notice the radical itself is not isolated. We have a term in front of it, a coefficient of 3, and we also have a sum of 15 to the right of it. So what we have to do here first is we have to first isolate the radical itself using inverse operations. In other words, you want to move anything outside of the radical away from it to the other side. Then we will apply the power to both sides. So first thing we want to do here is subtract 15, and then we're going to divide by 3. Now at this point, our radical is isolated. Now we can apply a power to both sides in order to extract the root inside, or the radicand inside here. So remember, what we do is we try to raise a power on both sides that will simplify with the root here. Well, the root is 3, so we're going to apply a power of 3 on both sides. Okay, we have an answer, but remember, we have to now check it with the original problem here, because it is possible this could be extraneous. When we apply powers to both sides, we could unintentionally create an extraneous solution. So we're asking the question, if I plug in negative 125 into the left side of the equation, because that's what the equation tells me to do, the x is there, will I end up with 0? So what I'm going to do here is 0 is going to stay on the right hand side, nothing moves to the right or nothing moves to the left. All I'm going to do is simplify the left hand side. As you can see, we ended up with a true statement. By the way, don't always assume that's the case. Take the time to work this through. So since this is a true statement, then I know for sure negative 125 is the solution to this equation.